To solve this inequality, let's start by adding x to both sides. And actually, in the same step, we could add 5 to both sides. Nothing about this changes the inequality, but what we end up with is 3x on one side, 15 on the other, and less than still holds true. We can then divide both sides by 3, and this gives us an answer of x is less than 5. I'll start by distributing the negative 3, which gives us negative 3 plus 3x plus 5 is greater than 0. If I combine like terms, we get 3x plus 2 is greater than 0. I will subtract 2. And I'm dividing both sides by a positive number. It does not matter that this is a negative 2. The thing I divided by is positive. This means that the direction of the inequality does not change. And we have x is greater than negative 2/3. So to solve this one, I can go through and distribute the numbers into the parentheses. This gives us 5x minus 15 plus 2x minus 2. That is still greater than or equal to 8x minus 8 plus 4. Going through and combining like terms, let's see, we get 7x minus 17 is greater than or equal to 8x minus 4. Simplifying either side does not change the inequality, that's fine. I think what I'll do is subtract 8x from both sides, as well as add 17 to both sides. You can do that all in one step. We get negative x is greater than or equal to 13. And maybe I'll put this in here. That's really a negative 1 if you would like, because we're going to now divide both sides by a negative number. This will change the direction of the inequality. We get x is less than or equal to negative 13. So we can distribute the decimals into the parentheses, but if we actually multiply both sides by 10 first, so as my first step, maybe let's make a note, I'm going to multiply everything by 10. That will change these numbers by 1 decimal. This whole problem becomes 3 times x plus 2 plus 5 times 1 minus 3x. Where is that less than or equal to 2 times x minus 8? So at this point, I multiply by a positive number. The direction of the inequality does not change. I'll distribute in the 3, the 5, and the 2. So we get 3x plus 6 plus 5 minus 15x is less than or equal to 2x minus 16. If I combine like terms, okay, we get negative 12x plus 11. That's less than or equal to 2x minus 16. I think I will subtract 2x as well as subtract 11. And we get negative 14x is less than or equal to negative 27. I'll divide both sides by negative 14. Here I'm dividing by a negative number that changes the direction of the inequality. We get x. It's greater than or equal to, and if we simplify this, we get a positive 27 over 14. For this problem, I'm also going to multiply both sides by 10. It's going to be a little bit different here, and that's precisely what happens in this step. If you multiply this whole term by 10, you can make this 20, or if you move that 10 into the parentheses, it would distribute to both of those terms, making this a 1 and this a 5. So I'm going to do it that second way instead. That is, after multiplying by 10, I get 8x minus, again, I'm not going to multiply the 10 to this 2. Instead, I'm going to move that 10 into the parentheses and multiply it to both terms, which gives me x plus 5. On the other side, I get 1 minus 2x. I'll now distribute this negative 2. Combine like terms. I can now add 2x to both sides, but also add 10. You can do this all in one step, no problem. So that's 8x is less than 11. Dividing both sides by a positive number 8 gives me my final answer of x is less than 11 over 8. Okay, here I'm going to multiply both sides by the least common denominator of 4 and 5, which is going to be the product of those two numbers, which is 20. This means I'm multiplying 20 to every single term. I don't need to make that last one a fraction because this is not a fraction. Anyway, that's a positive number. It will not change the direction of the inequality. So that is 20 over 1 times 1/4 x minus 20 over 1 times 1/5. And that still is greater than 20 times negative 1. I'll put some parentheses there to avoid confusion with the negative. Okay, this goes in 5 times. This goes in, obviously, 4 times. And what we have left over is 5x minus 4 is greater than negative 20. All right, so now if I add 4 to both sides, we get 5x is greater than negative 16. Dividing both sides by 5 yields my final answer of x is greater than negative 16/5. Okay, so here my least common denominator is going to be 4. So that means I'm multiplying 4 to every single fraction. Except on the right side where 4 gets multiplied to both terms. This is 2x plus 1 over 4 minus, then we got 3x over 2 is greater than or equal to 4 times x plus 4 times 8. On the left side, those completely cancel. This leaves me with a 2. I can now simply multiply through. This is 1 times 2x plus 1, so I'll just put 2x plus 1. Minus 2 times 3 is 6x is greater than or equal to 4x plus 32. Combining like terms, we get negative 4x plus 1 is greater than or equal to 4x plus 32. I will simultaneously subtract 4x from both sides as well as 1. I get negative 8x is greater than or equal to 31. Here I'm dividing by a negative. That's going to change the direction of the inequality. My answer is x is less than or equal to a negative 31 over 8. Okay, my least common denominator is 6. If I multiply that to every single term, for this first one there's a negative, so I can just put that 6 over 1 directly in front of it. So I'm left with x plus 2 over 3. Again, that negative I just moved out to the front. Okay. Canceling my factors. I have to be careful with parentheses in the first expression. That's negative 2 times parentheses x plus 2. Plus 3 times x is less than 1. If I distribute in that negative 2, I get this. Oh, so this simplifies to x minus 4 is less than 1. If I now just simply add 4 to both sides, I get my final answer of x is less than 5. The absolute value of x is greater than or equal to 4 breaks up into two pieces. One is x is greater than or equal to 4, if you just forget about the absolute value. But you get a second one, and that is x is less than or equal to negative 4, and this is an or statement. So this is the solution, but for this one, I think I'll at least put it on a number line. What happens is you have 4 and negative 4. To say that you're greater than 4 means, okay, you're at 4 and you're going this way. but you also get everything at -4 and what is less than it. So here's the solution on a number line to the inequality. For this one, we need to do a little bit of work, but it's now a less than. This means we're trapped between two values. This means x plus 1 is less than 7, but it also means it's greater than -7. So this is an AND statement, and anytime we have an AND statement, we'll just condense it into one expression. To solve for x, I can subtract 1 from every single side of the inequality. I get -8 is less than x is less than 6. You could draw this answer on a number line. Maybe, again, for this one, I will, just because it's the other possibility from an OR. We have everything between -8 up to and not including 6. So the answer starts here, it ends here. Since we're saying less than, you are trapped between two values. Okay, so for this one, it's greater than, which means we have an OR statement. This is x minus 5 is greater than 1, or it could be that x minus 5 is less than -1. We have to solve these separately by adding 5 to both sides. And what we end up with is x is less than -4, or x is greater than 6. Okay, for this one here, we have a less than, which means we're trapped between two values. This means 3 minus x is less than or equal to 2, or it's greater than, and it's greater than -2. So to solve this one, I'm going to first subtract 3 from all sides. This gives me -5 is less than or equal to -x is less than or equal to -1. You now have to divide by this -1 to get rid of it from in front of the x. But you're dividing that to every single term. And dividing flips the direction of the inequality in both cases. So we get 5, we get x, we get 1, but this is now 5 is greater than or equal to x is greater than or equal to 1. And typically this is written in increasing order, so there's, I guess, nothing wrong with the statement I have written, but I would write this as follows. Okay, we have another less than. So this means -x plus 1 is less than 9, and it's greater than -9. I'll subtract 1 from everything. And then, since there's this 1 here, I'll divide everything by -1. My answer is 10 is greater than x is greater than -8. And I'll flip this around to be -8 is less than x is less than 10. Okay, here we have something that'll be an OR statement. This is saying that 1 minus 5x is greater than or equal to 14. Or, as another possibility, maybe 1 minus 5x is less than or equal to the -14. So we have two distinct pieces. In all of them, we'll subtract 1 from both sides, giving us -5x is less than or equal to -15, or -5x is greater than or equal to 13. In both cases, you'd have to divide both sides by -5. This will change the direction of the inequality. On the one on the left, we have x is greater than or equal to 3, or x is less than or equal to -13/5. For question 15, I've set up the variable to be the concentration of alcohol in the final mixture. That's the thing we're solving for. If we mix these two things together, there's an additional piece of information you can infer. 12 ounces plus 4 ounces means that the number of ounces in the final solution is going to be 16 ounces. I can use this picture to now set up my equation. One side is the amount of alcohol on the left, the other is the amount on the right. That is, this is 0.05 times 12, the amount of alcohol in the first mixture, plus 0.45 times 4, the number of alcohol in the second mixture. If you pour these together, it's going to be some concentration of alcohol, and then we have 12 plus 14, the amount of liquid in that final container, which I know is 16. The rest we're just going to get by plugging things into our calculator. So if we have 12 times 0.05, that is 0.6 plus 4 times 0.45, 1.8. This is equal to 16 times x. Okay, so simplifying, we get 2.4 is equal to 16x. Therefore, we have to divide both sides by 16 to get our final answer. And we get 0.15. And the way we set this problem up, or at least the way I set this problem up, since I converted all of these numbers to decimals, at the very end, this x would have to be converted back to a percent by multiplying the number by 100, or just moving this decimal 2 places. That is my final answer. X is equal to 15%. For 16, the variable this time is not a percent, but it's a number of ounces of 80% alcohol that you're adding to take this 50 ounces of 25% alcohol up to 75% alcohol. So the setup is the same, it's just our variable is in a different location. Okay, we are pouring 80% alcohol into this thing right here. So it's got to be that we have 80% over here. I'll go ahead and fill that in. And the amount that we're pouring in, I just don't know what that is. I'll just have to call it X ounces. It's some number of ounces. We want the final thing to be 75% alcohol, and the amount of stuff that is in it will also include a variable. It's going to be 50 ounces plus X ounces. I'll leave off that ounces there, but it is in ounces for sure. If I now translate this to an equation, that's 25 times 50 plus, that's 0.25 times 50 plus 0.80 times x is equal to 0.75 times 50 plus x. The parentheses are very necessary here. Let's start simplifying. Okay, so we get, we get 12.5 plus 0.8x is equal to 37.5 plus 0.75x. I suppose the approach I'll take is subtracting the 0.75x from both sides. And in the same step, why not just take away this too? And what we are left with is 0.05x on the left. On the right, we have 25. I will now divide both sides by 0.05. And the x value I get is 500. And this is 500 ounces. It's quite a bit, but that makes sense. I mean, I figured it would have to be a lot. We're going pretty far from 25% up to 75%. And these two percentages are close together, so I figured it would take quite a bit to do that. This is my final answer. So for 17, we're actually decreasing the concentration of acid. We have something that is 15% acid, and we have 2 liters of it. So again, that's 2 liters of something that is 15% acid. And to this, you want to lower it to 5%. That's the goal. You need this 5% acid for our experiment. Adding pure water, pouring that in, should accomplish this goal. I just don't know how much. It's going to be some number of liters of water. And now we have to infer what the percent of acid in pure water is. And what do you know? It is 0%. The amount of liquid in the final mixture is going to be 2 plus x liters. I think we can now set up our equation. We get 0.15 times 2 plus, turns out we don't even need to write this. I mean, 0% is 0.00 times x. That ultimately is going to go away. And on the other side, we have 0.05 times 2 plus x. Let's start simplifying this. We get 0.3. We don't even need to write the next term. And when you distribute in the 0.5, you get 0.1 plus 0.05x. A fairly simple equation to solve. We get that 0.2 is equal to 0.05x, after dividing both sides by 0.05, 0.05, and 0.2 divided by 0.05 is 20 divided by 5, 4. So this is 4, and that is 4 liters. You have to pour in 4 liters of pure water to drop the percent of acid from 15% down to 5%. For this problem, my variable is going to be milliliters of pure alcohol added. And what we're trying to do is take something that is 95% alcohol. So we have this 95% alcohol. And it says we have 2 liters of it. I want to be careful here. I'm going to convert the 2 liters to milliliters just so our units match up. That's important. I mean, your units have to be consistent throughout your problem. So here, instead of 2 liters, I'll put 2,000 milliliters. Okay, with this change, it's now asking how many milliliters of pure alcohol, so that's 100% alcohol, do you mix in to end up with something that is 95.01% alcohol. And that's going to be 2,000 plus X milliliters. Anyway, the equation will be 0.95 times 2,000 plus, well, 100% is just 1 times X. I could have just put X. And on the other side, I have 0.9501 times 2,000 plus X. Okay, let's simplify this out. Okay, we get, this is 1,900. I'll just call this X. Distributing the 0.9501 gives us 1900.2 plus 0.9501X. What I'm going to do is subtract this from both sides. As well as subtract this from both sides. And when I do this, okay, we get 0.0499x. That's 1 minus 0.9501. And that's equal to, okay, that's just 0.2. Dividing both sides by this amount. Let's see, I'll do that in my calculator here. Okay, we'll have to round it. I think it kind of makes sense, maybe even to round this one out to 3 decimal places. I mean, you could go out to 2. There's nothing wrong with that. The further you go, the more accurate your answer will be. X is equal to 4.008. That is milliliters of pure alcohol that would increase the concentration from 95% to 95.01%.